Hi everyone. So I am Umakant. After a lot of time, I am making a video. So I am in fourth year of my PhD. So work is going on. So getting no time for these videos. Still, IUSC interview is there. IUSC Scientist-C interview is there. So lot of students have written me about the questions pattern for the interview. सो आपको पता है मैंने 2022 में IUAC का रिटन दिया था. मेरा फ्रेंड यहाँ से IIT बॉम्बे से जिसका रिटन क्वालिफाई हुआ था, उन्होंने इंटरव्यू में अपीयर किया था. ओके, ही इज़ फ्रॉम फिजिक्स डिपार्टमेंट. ही वाज डूइंग हिज PhD इन फोटोनिक्स. सो उसका नाम विकास था. सो वो अभी IUAC में साइंटिस्ट है. तो उससे मैंने कुछ क्वेश्चंस कलेक्ट किया हूँ, जो क्वेश्चन मैं ये वीडियो में बताने वाला हूँ कि एग्जैक्टली व्हाट दे हैव आस्क्ड विकास. सो आई थॉट आई हैव टू कन्वे द क्वेश्चन, सो दैट्स आई एम मेकिंग ए वीडियो. So first of all, the interview will be like BRC, but the time duration will not like BRC. In BRC, you know कि interview duration is like 1 hour, 1.5 hours. But here the time duration will be 25 to 35 or 45 minutes, max to max 45 minutes. Okay. So there will be 3 persons in the panel. They will ask you the same way कि what you have prepared. So you have to just tell 2 to 3 subject as per you have prepared. So then they will ask various type of questions out of them. So they will try to make questions on your answers. So be careful on that. विकास को वो लोग पूछे थे कि विकास फोटोनिक्स में काम करता था, तो उसको पूछे थे कि लेजर के बारे में बताओ, लेजर कैसे काम करता है. सो व्हाट इज द प्रैक्टिकल एप्लीकेशन ऑफ लेजर. जैसे आपको पता है लेजर इज ए लाइट सोर्स. ओके, इट्स ए मोनोक्रोमेटिक सोर्स ऑफ लाइट. So it will provide a particular wavelength of light. It may be in UV, it may be in visible, or it may be in infrared region depending upon the laser. So लेजर को लेके आप क्या कर सकते हो, एक्सपेरिमेंटल में क्या बेनिफिट्स आपको मिलता है. तो जैसे आपको पता है, इसका सही से आंसर यही बता सकते हो कि लेजर को आप स्पेक्ट्रोस्कोप में यूज़ करते हो, जैसे रमन हो गया, और प्रैक्टिकल एप्लीकेशन में यूज़ करते हो, फोरियर FTIR में यूज़ करते हो, राइट. देन डिवाइस, सेमीकंडक्टर डिवाइस में जिसमें फोटो डिटेक्टर्स आप स्टडी करते हो कि वेदर दिस डिवाइस विल एप्लीकेबल एज ए फोटो डिटेक्टर और नॉट, वेदर इट इज ए UV डिटेक्टर और इट विल बी IR डिटेक्टर, डिफरेंट काइंड ऑफ थिंग्स. बट in detector perspective you need a light source, and that light source can be a laser or it can be a halogen or a xenon lamp also. So depending upon the wavelength and your material band gap, you have to choose the laser. So both the spectroscopy or optics perspective as well as for the device perspective, you can have this laser use. Okay, so optoelectronics device has this laser use. Then they have asked about ruby laser, ki how a ruby laser is working. Then they asked about how to measure the energy density of the laser. So how to measure the energy density, you know. So practically in lab we are using power meter to record the energy of the incoming laser, and depending upon the spot size, okay, so you can measure the diameter of this laser beam. So you can make a pi r square area. Then this area will be divided by energy. So area by energy by area of this laser will give you the energy density. And for this energy measurement, you have to use this photo power meter, which is a basically semiconductor photo detector. Basically nowadays people are using silicon photo detector, which is a standard photo detector. So then they asked various questions from suppose electronics. Yeah, electronics was there. They asked about this PN junction, how a PN junction is formed, how depletion region is formed. Can you draw the energy band diagram of this PN junction? Then they have asked about this field effect transistors. Okay, how this transistor works. You know this IDVG and IDVDS curve, output and transfer characteristic of FET. Then they have asked little questions from mathematical physics. They asked about Fourier transfer and little bit about the Fourier transfer. They gave some functions, so you have to transfer in the Fourier space. Then I have to calculate how it will look like in Fourier space. So the point is like they will ask about the basic questions. Okay, no doubt they will go into basics. So it's all about you to answer them satisfactorily, and you have to try to convince them and try to explain them. Okay, not try to just say the things straightforward. No, you have to go into the physics aspect, how it is working, what the equation, what the model you are using to explain the things, how the real physics comes into the picture. That is the thing, they will check your fundamentals. Okay, so similarly, but apart from that, I can suggest you one thing. Before jump into the interview, you should be prepared 2 to 3 subject very well, like quantum mechanics, EMT, mathematical physics, semiconductor physics. So nowadays semiconductor becoming a hot area of research. It's always a hot area of research, but nowadays in interview they are trying to push you into the semiconductor world. So read about semiconductors, how a N-type semiconductor form, how a P-type semiconductor form, what will happen if you make a PN junction, how a transistor works, how a photodetector, solar cell is working, how you can build a solar cell, how you can make a MOSFETs, you can make a optoelectronic device in the lab. So make some idea out of it, because lot of NPTEL classes and lot of video lectures are available in YouTube, and the special person they are focused onto the devices, how the device architecture is there, how you can fabricate different logic gates, integrated circuits, how they are working. Okay, so basic electronics, basic semiconductor physics, like effective mass, band theory, Kronig-Penney model, how really effective mass works. Okay, how you can tune the effective mass of a semiconductor by means of the experimental way, right? How you can tune the property of the material. Okay, not only band gap, photoluminescence, etc., but how you can change the effective mass, so that you can change the mobility, you can change total transport property of the material. So just think about this by experimental way, how you can tune these properties. Okay, so don't go with the equations only, don't need go with the mathematical formulation. So just go inside the deep, try to understand the meaning of these parameters, how they are really affecting the practical devices, practical semiconducting materials. Okay, the same way you just think before going to the interview. Like in BRC last time, the people have asked me about a thermodynamic problem, but they have asked me a practical problem from structural crystallographic. Like in a unit cell, if you put some foreign particle, or you are extracting some atoms from the unit cell, so what will happen to the unit cell? Oh, okay, so what will how this defect, the defect that will created, how it will affect the band structure. Okay, that band structure is the key of the semiconductor. You can tune both optical and electrical property of this material by tuning this band dispersion. So how the band dispersion is really affected by the external factor, like strain, like dopant, like temperature, like pressure, everything you can tune, but depending upon the material quality you can tune this property. So just it's a brief overall I am saying, but there is a lot of story behind it. So you just try to understand when you are reading a semiconductor physics. Okay, the same way quantum mechanics, like electronics, like EMT, classical mechanics, whatever you are reading, you just go through the books and try to understand the real problem. Okay, and try to ask question yourself, then only you can answer them. Okay, so be with the flow and read as per your potential, and try to understand the things and go with the flow. Have a good luck, wish you all the best for the interview. Thank you so much. And after a long time I am coming in YouTube, so I hope your support will be there, and I will continuously putting videos regarding different techniques, like how we are working in lab, how what we are doing, how we are fabricating devices, like transistors, different logic gates, like neuromorphic devices. So I'll say about you in detail. So work is going on. I'll be in my final year soon. So hope you will support to my channel. Hope we'll meet like this. Okay, thank you so much. Thank you. Bye bye.